Hey everyone, welcome back. In today's video, we will be talking about API key authentication. That is how to authenticate a user or an entity using API keys. And we will also learn the concept of pre-authentication. But before that, if you haven't watched the first video, please do so because we will be relating the core concepts like Spring Security Filter Chain, Authentication Manager, and Authentication Provider. So let's get started. So let's start by understanding what is pre-authentication. Pre-authentication is a security pattern where the user or the entity which is being authenticated is already authenticated or verified before the request reaches to the backend application or API. Now, this sort of activity usually happens upstream. This is an upstream job. That means there could be an API gateway, a load balancer, or any other external service that is responsible for the initial authentication. So by the time the request hits the API or the backend service, we already know who the entity is, who the client is. The only job of the API or the backend is to authorize or to validate the key in order to provide the access to the secure endpoints or resources. So in this case, the user is already authenticated and the user only provides the API key, not the full username and password. When do we use the pre-authentication, the pattern of pre-authentication? We can use pre-authentication in certain scenarios, like whenever we are offloading the authentication mechanism to another system, like an API gateway or external service or any other identity provider, there we can use the pre-authentication. Or when the backend services or the APIs are supposed to trust only pre-authenticated requests. In those cases, we can use the concept of pre-authentication where we can allow or disallow the access without handling login sessions. We will see in a demo in a bit how to pass the API keys to the backend application and how to allow or block the access depending on the API key validity. So let's understand how it works. So here we can see a sample request on the Postman. We don't need to worry about this endpoint. The important thing is, in order to access any secure endpoint, we need to authenticate the entity first. And how we do that in Postman, there is this authorization tab where we select a particular authentication type. So in the previous demos, we selected, for example, basic auth for the basic authentication. For example, if you are implementing JWT, then you will select the JWT bearer token. For example, for OAuth, it will be OAuth 2.0. Now, in case of API key authentication, we select something called API key. And when you select the API key, there are a couple of options that we can select. For example, what is the key? Here we can provide or define a custom key in which we will pass the API key. Then goes the value, so it could be your API key. And the third option is, how do you want to send this API key? There are two options in Postman, whether you can pass it via header or you can pass it via query parameters. Now, if you're not using Postman, maybe another CLI tool or maybe a Java client, in that case, you will have to set the authentication type and you need to pass the API key either via headers or query parameters. Now, once we pass the API key, the request will hit the backend. The backend will extract the API key either from the header or from the query parameter. The next step would be to validate the key. So there will be a data store where all the keys will be stored in advance because we know the user is pre-authenticated. That means we already have the user information. All right. So the key will be validated, and if we find the key is valid and already present in the data store, then the access will be allowed. Otherwise, the user will be blocked. So that's how the API key authentication works. So now that we understand what API key authentication is and how it works, let's understand what we are going to do in this demo. So whenever we deal with API keys or any keys for authentication, there are certain things that we need to understand. So for example, the first step would be to generate the key, okay, where the user will be assigned a new key that the user will use for the authentication purposes. Now, when you have the key, we need to have the flexibility to invalidate the key. So for example, the key is corrupt or maybe leaked. In that case, we should have the ability to invalidate a particular key for security purposes. Then there is this third functionality to rotate the key. Now in this approach, what we do, we disable the previously generated key, then we generate a new key. Now in this demo, we will not cover this part because here we are assuming that the keys are already present in the database and we will simply use one of the keys to access a secure endpoint. Okay. So we will not implement these three functionalities, but I will share the reference code that you can explore and practice in your own time. But implementing this is a very simple task. We can implement this same as any CRUD application by having a data store. So for example, in this case, we can have a MySQL database, then we can have a Spring Data JPA repository, and maybe a simple API key JPA entity. And after that, these will be simple CRUD operations. I will share the code. Now, as I said, we are assuming that the keys are already present in the database and the user will hit a secure endpoint by passing it a key. So in this demo, we will have a secure endpoint, for example, /API/create. Okay. So when the user accesses this endpoint and passes the API key, it will trigger the Spring Securities filter chain. And then we will add a new API key filter. And the role of this filter will be to check the API key in the header that we discussed. It will validate the key. If the key is valid, then it will allow the call. And how it will allow the call? It will do so with the help of something called authentication provider. So we will also implement a custom authentication provider to authenticate an entity depending on the key available. Okay. So there are two important classes that we will see in action. The number one is abstract pre-authenticated processing filter. So that is the same filter that we will override. Then we will also see the use of pre-authenticated authentication token. So in a nutshell, we will write a new API key filter and a new authentication provider. Let's now cover the implementation part. So for this demo, we are not going to implement the user registration part. That means for this demo, we are assuming that the system already has the user. And if you really want to implement the user registration part, then you can refer the previous videos in the same playlist where I have covered how to manage or how to implement the user registration part using MySQL database. In that case, you will need a MySQL database, for example, additional controllers to expose the registration endpoints, and then the usual logic and services to implement the CRUD operations. And second thing is, we will also not implement the key generation part or other operations related to key management. The reason behind this is we are assuming that there would be another backend service or another flow which will be responsible for key management. So there could be an entirely different application to generate the keys, to rotate the keys, assigning the keys to users, and so on. So A, we are going to assume that the user is already present in the system, and B, we will assume that the user already has the API key. So in this demo, we will get the API key from the user as part of the request, and then we will validate the request. But suppose you want to learn how to implement the key related operations like generating a key and assigning it to the user, or invalidating the key or rotating the key. So for that, I will share the sample code in the same code base and I will give you a walkthrough. You can refer the same code and implement those operations in your practice project, for example. So the code is already present in this demo code base. That is the part that I have already done to save some time. But please note, we are not going to use that code in the key authentication part. So let me give you a quick walkthrough. The first one could be the application.yaml file. So you could have a MySQL database to store the keys and the user information. Although for this demo, we are not going to use the MySQL database. This is just for the reference so that you can implement the key related operations. Okay. So the first thing is we need a user store. So you could have any user store. In this case, it could be a MySQL database. Then you would expose some endpoints basically for key management. For example, you could expose an endpoint to generate the key where you would get the user information or the owner of that key. And then using this service, you can generate the key and return it back to the user. Then another endpoint could be to revoke the key. For example, you have to invalidate a key. So there will be an endpoint where you will accept the key and then internally you will revoke the key. You will invalidate the key. The third endpoint could be to rotate the API key. So for example, the user will pass an existing key. Then the job of this endpoint would be to coordinate with this service and deactivate this particular key, generate a new key and return it back to the user. Now, as I said, we are not going to use this code. This is just for the reference here. You can see the same thing in the comments as well. Then you could have an API key service. And here you can see we are using password encoder and I will explain why. So for example, to generate the key, the method would look something like this. So here you can see we are generating a key, which is simply UUID. Okay. Then we are creating a JPA entity, which will be used to store the API key in the database. This represents an API key. And there are simple columns like primary key, the actual API key, who is the owner, is the key active, the create date, and when the key will expire. Now coming back to the API key service, the task is simple, create the JPA entity. Okay. Set the corresponding attribute. So here, instead of saving the key directly, we can use the password encoder basically to hash the key. So even though we are generating a UUID and the same will be returned back to the user, but in the database, we can hash the key before saving it. So that's why we are using the password encoder. All right. And then using the same Spring Data repository, okay, you can see the repository here. This is a very simple repository. So using the same Spring Data repository, we are saving the key in the database. So that is the part where we can implement the generate new key functionality. Now, similarly, we can have a function to invalidate a particular key. So for this demo, for example, we have the pattern something like this, where the key is actually a concatenation of the owner name and the actual key. So when the user passes the key, okay, we can split the key, get the owner, then using the repositories find by owner and is active true. This is another method that we added to the repository. So you can see the implementation. This is simply a method. The implementation will be generated by Spring at runtime, okay? And we are passing the owner. So here we are simply fetching the key by this owner and it must be active. So an active key for this owner, okay? And if the key is present, then we are deactivating the key by simply updating the active status to false. And again, saving the data in the database. So that's how we can implement the invalidation part. Similarly, if we talk about the rotate keys, we get the key, we get the owner, okay? We fetch the key from the database. If the key is present, then first we need to deactivate the old key. And then we can generate a new key by using the password encoder and the new create time and the expiration time. And we can save the new key and return it back to the user. So this implementation is just for your reference in case you want to implement the key management operations, but we are not going to use this in this demo. So having covered this, let's focus on the stuff which is related to this demo. So the first one is greet controller, and it represents a secured endpoint. So when the user accesses this endpoint, it will be validated by using the API key. Okay, so only if the API key is valid, then the user will be able to access this greet endpoint and we will see a success response that, well, you're allowed. In the pom.xml, we have added simple dependencies like Spring Data JPA, although we are not going to use it. This is just for the reference to implement the key management operations, which I explained. The important thing is we need to add this Spring Security dependency and web, because this is going to be a REST API. And the last step is the key store. Now this is a class which holds the dummy data. It represents the key store, but in reality it will be a real data store where we will store the keys like a database or any other third-party solution. So in this dummy database, we have a single map, okay? And in this map, we have a single entry for user John. So this is the owner of the key and this is the key in the hashed form. So now when John accesses the greet controller, the secure endpoint, it will pass an API key and we will write the functionality to match that API key with this hashed key. All right. If the key matches, then that means the key is authenticated, key is valid, and John will be able to access the greet controller, basically the endpoint. Otherwise, it will get a 403 exception. So the next question is, how do we start and where do we start? Well, if we go back to the diagram, you see the first thing is we will add an API key filter. Okay. And this API key filter will extend from this filter, which is abstract pre-authenticated processing filter. So when the user hits the endpoint /API/greet, okay, it will trigger the Spring Security filter chain, and Spring Security filter chain will call the filter that we will add. And from there, we will start the API key authentication or validation. So let's do that. So we will start by adding a new filter, and this filter will intercept the incoming request. It will extract the API key available in the request, and it will pass the key down the chain for further processing. So let's do that. Let's add a filter first. And we will name it API key filter. Something like this. Now, as we discussed, what this filter will do, it will extend an existing filter which is responsible for pre-authentication flow. And that filter is abstract pre-authentication, this one. And it has two methods. The first one is responsible for returning the principal which is being authenticated, and the second method returns the credentials if available. Now in this case, the principal would be the key itself, so we will return the key from the first method, but since there are no other credentials, so we'll simply return a dummy value from here. Now this returns object, so we can say something like this, NA, because it does not exist for this case. Now from here we need to extract and return the passed API key. So how do we do that? So we know the filter will intercept the incoming request, and we also know that the user will pass the API key in the request header. Now in this method, we have access to something called HTTP servlet request. So that means we can fetch the headers from this request. And in order to read the header from the request, we will use the method getHeader. Now, if you remember, if you go back to the Postman, the name of the header will be x-api-key. This is a custom header that we will provide. All right. So let's pass the header name x-api-key. So this filter will intercept the request and it will read the keys from the request header. All right. Now, if we check the abstract filter, what it does, so there is a method doAuthentiCate, which is responsible for the authentication. So you can see the first thing it does, it reads the principal by calling this particular method, which will return the principal now because we are implementing or extending the filter. All right. And once it has the principal, it creates something called pre-authenticated authentication token. All right. And after creating the authentication request, if you notice, it calls the authentication manager. And if you remember the security architecture from video 1, the authentication manager is responsible for the authentication, but the actual responsibility is delegated to something called authentication provider. So in this case, we will also write an authentication provider, which will do the custom authentication for API keys. So let's add a new custom provider. And we will name it API Key Auth Provider. Now it must implement the authentication provider interface, this one, which is coming from the Spring Security, and we will also implement the abstract methods. So there are two methods. The first one is responsible for the authentication, and the second one acts as a filter in case you need to filter out the requests, because not every request must be authenticated by all the providers. Because if you remember from the first video, we have the authentication manager. Then authentication manager maintains a list of authentication providers. Depending on the authentication method or the authentication mechanism, authentication manager picks a certain authentication provider. So in this supports method, which returns a boolean, will return a flag whether this provider handles a particular kind of authentication method or not. So in this case, how do we do that? Now, if we go back to the abstract filter, you see it creates this token, which is pre-authenticated authentication token. And this is present in this request, and this request is being sent to the authentication manager, as you can see here. So what we will do in the provider supports method, we will check if this token is available, the instance of this token is available. Like this. And if it returns true, that means this provider must authenticate the request. Then the second step is to actually perform the authentication. Here, if you notice, we are getting the object of authentication. And from this authentication object, we can actually get the principal. And that principal is nothing but the API key, because this is the principal that we returned from the filter. So in the provider method, we will get the principal, which is nothing but the API key in this case. So we will do something like this, authentication dot get principal, and it returns an object. So we need to typecast, because in this case, the principal is simply a string value. And then here we will validate the key by comparing it to key store dummy value. Now, if you go back to the Postman, if you notice, the key has two parts. The first one is the owner, then a delimiter, and then the actual key. It doesn't have to be like this. It's just how I created the key. It's up to you. It's up to the use case. Now, in this case, because key is a combination of the owner name and the actual key delimited by double hash. So what we need to do, we need to split the key. Okay. And then we will have the owner and the key. Then we will go to the key store by calling this name. We will get this key by the owner name. Okay, so let's go to the authentication provider. Now we can do all the things here, or we can follow the same pattern that we have a service already. So we can auto wire it like this, private API key service, and then we can pass the request to this service. So we will have an implementation something like this: API key service dot is key valid. This method does not exist. We will write it in a bit by passing it a key. If the service method returns true, if the key is valid, then we will return a token that represents a successful authentication, which is username password authentication token. And it has multiple constructors. So let's check the constructors. And this one accepts the principal and the credentials. And this one accepts the principal, the credentials, and the authorities. Now, in this case, because we only have the principal, we don't have authorities. So what we can do, we will pass the principal, which is key in this case, and we don't have credentials. So we will simply pass the null. That's it. But let's say if the key is not valid, in this case, this check will return false. And in that case, what we can do, we can throw an exception, bad credentials exception. Okay. And we can also pass a method invalid key, the key that we received in the request, and it must be throw not return. Okay, now we need to write this method in the API key service. Okay, so let's create the method is key valid in this service. Now in this service, we already have these methods for generating the key, revoking the key, and rotating the key. So I'm just reusing the service. You can write your own. All right. So the first thing that we will do, I will copy the code because the key contains the owner name as well. So we will split the key. Now we have the owner and we also have the key, which is the raw key. All right. And once we have the owner and the raw key, we simply need to go to the key store and find this value. So that must be static in this case. All right. Going back to the API key service, we will say hashed key equals to key store dot get key by owner, and we will pass the owner here. Now suppose when you are storing the data in the database, instead of calling the key store, you will actually make a DB call to fetch the key by owner. Okay, in that case, the key will be fetched from the database, the hashed key basically. And once we have the raw key and the hashed key, we can actually compare both the keys to validate if the key is valid or not. Now, if you notice, if we go back to the key store, this is actually a hashed key, which is encrypted by the bcrypt password encoder, all right, which is available here. Now, because the password encoder was used to hash the key, so we need to use the same password encoder to match the key. How do we do that? Well, doing that is very simple. We have the instance of password encoder and it has a method matches. And this method accepts two parameters. The first one is the raw password, which is raw key in this case. And the second one is encoded password, which is the hashed key. All right. Because the key was actually encoded by the password encoder, so there is no way to decode it. We'll have to use the matches method of the password encoder, which will automatically compare and return true if the keys are equal, otherwise false. Now that we have the API filter and the authentication provider, how do we inject everything together so that we can have a running demo? And we know in order to configure the security part, we need security config. So we will also add a security config class, basically a configuration file. Like this. And this must be configuration. And in the security config, we need to configure the security filter chain. So we will create security filter chain. And this will have access to an object of HTTP security. Like this. And then we need to configure the chain. And we know how to do that. We have already covered this bit in previous videos. Okay. So the first thing that we will do here, we will disable the CSRF because this is purely a backend application. All right. Like this. We need to throw the exception. Then we will call authorize requests. And here we will say auth dot any request dot authenticated, which simply means authenticate each and every request. There are no exemptions. All right. Now, how do we tell Spring Security to use the filter? We have to tell Spring Security that we have a new filter, so you need to use that filter. To do that, we actually need to pass the filter manually. So here it is. And then because we are extending the abstract authenticated filter, we need to pass the authentication manager as well. And we will say set authentication manager. And how do we get the authentication manager? Well, we will inject the authentication manager. We don't need to create it from scratch. It will be done by the framework. We simply need to inject the authentication manager. But the thing is, as you know, we have also created the custom authentication provider. So we will assign this provider to the authentication manager, and then we will inject the authentication manager here. So that we know how to do that. It's simple Spring, basically creating the beans using Java config. So we will have a method in the same configuration class, and we will return an authentication manager in this case, which is nothing but an object of provider manager. And this authentication manager will have a collection of authentication providers. In this case, a single item, so a singleton list, API key auth provider. And how do we get this API key auth provider? Well, we already have the bean or the provider class. We simply need to inject it. That we can do here. Like this. So we have the authentication manager. This authentication manager is referring to the authentication provider that we created. And this authentication manager is then passed to the filter. And so we will have a valid filter. Now this is raising an error because yes, we need to pass the authentication provider. So instead of passing the parameter, let me auto var it like this. Now this is good. Okay. So once we have the filter, as I said, we need to inject the filter. And in the security config chain, in the security filter chain, there is a method add filter. Now you see there are various methods, like let's say if you want to add a filter, if you want to change the sequence. So there are methods like add filter before a particular filter, add filter at a location, or add filter after, basically add the custom filter after a predefined filter. Now in this case, we will use add filter before. So the first argument is the filter that we want to add. And in this case, this is nothing but our filter that we created and the before filter. Now this before filter is nothing but the same abstract filter that we are overriding. So we want Spring Security to actually call our filter first before it calls the abstract filter. All right, like this. And that completes the code. So let's revisit what we did. The first thing we did, we created the filter. All right, and this filter is extending from the abstract filter. And from this filter, we are returning the principal, which is basically the API key. And we are getting the API key by reading the header. Then we also created the custom authentication provider by implementing the authentication provider interface. And in the authenticate method, we are simply getting the same principal, which is the API key. Then we are calling this service basically to validate the key, if the key is valid or not. And in this method, we are fetching the key by owner from the dummy database. And then we are simply using the password encoder to match the raw key and the encoded key. All right. Then in the security config, we are configuring the security filter chain. We are disabling the CSRF. We are telling Spring Security to authenticate all the requests. Then we are adding the filter. Let me do undo. And then we are adding the custom filter before the abstract filter. All right. And because this filter needs the authentication manager, so we are simply creating an authentication manager by providing it the custom provider. Now, if you are confused about authentication manager, security filter chain, and authentication provider, I recommend you watch the first video which covered the Spring Security architecture, where we covered these components, these classes. So we have the implementation ready. Let's start the backend and let's see if we can validate the key and if we can access the secure endpoint, which is this greet controller. Okay, so let me start the service. and we are getting an exception that it could not find the custom provider. And probably I know the reason. Let's go back to the custom provider. We forgot to use the annotation @component. That's why it's not able to inject the bean. Let's retry. All right, the service is up. And if you notice, it says that the global authentication manager configured with authentication provider bean with name API key auth provider. That means we are successfully injecting the custom authentication provider to the generic authentication manager. Now that this service is up, let's go back to the Postman and let me go to the new tab, because that is going to be a get endpoint. And it is /API/greet. Okay. And since we are using the API key authentication, so we need to set the correct authorization or the authentication mechanism. And here we will select the API key. And here you can see Postman is actually pre-populating the fields because I used them recently. Otherwise, you will have to enter the custom key that you created, or the header actually. And you need to select the header from the drop-down. And then you need to pass the key. Now in this case, because I already have the dummy data, so if you go back to the key store, now here you can see I already have an encoded key for the user John. So I'm going to use the same user, which is John, then the delimiter or the separator, and then the key. Now this is the same key which I encoded using password encoder that you see in the key store. All right, so we have everything ready. Let's hit the send button. So here we got a 403 response. That means for some reason the backend is not able to either validate the key, or there is some problem with the authentication flow. So let's check the logs, and we don't see anything unusual in the logs. So what we can do, probably we can go to the security config, and we know how to make some endpoints public or permit, and one of them is basically the error endpoint. So we want to see if there was any error, and we will say permit all. So let's restart. So by default, all the endpoints are authenticated. So that means if, let's say, there is an error and it is redirected to the error endpoints, then we won't be able to access it. That's why we are permitting the error endpoint, so that we can access or see any errors if occurred. So the service is up. Let's go back to the Postman and hit the same request. And you see this time we are getting an error exception because we have now excluded it. So this is still saying forbidden 403 and the path API greet. Now I know the key is a match because I generated the key, basically the dummy key, and encoded it using the bcrypt password encoder. So that is a perfect match. Then it calls the provider, it validates the key, and then it returns the token. And if we check this token, you see it is calling a method set authenticated, and it is setting the authenticated status as false. That is not what we want to do. We want to set the successful authentication in this case. So we need to call this constructor and pass the authorities as well. Now in our case, because there are no authorities, it is open to all. So we will pass the null. Now if you want to understand the authority, we covered the roles and authorities in the previous video, so you can check it out. And I will restart the service. So the server is up. Let's retry. And this time we see the success response that you are allowed. That means that was the missing thing actually in the implementation, but otherwise the keys are matching. If we pass a valid key, it will be a match, and so the access will be allowed. Now let's say if we change the owner in this case, or basically the key. So let's change the key. Instead of 3, let's change the last digit. So you see, by passing an invalid key, we are getting a forbidden response again. All right. So that is the API key authentication, in which we pass the API key as a custom header in the request. Then on this backend side, we intercept the request, we fetch the value from the header, and then we pass it to the authentication provider, which does the authentication. Now there's one last thing before we close. So if we go back to the key store, you might be thinking, how did we create this encoded key? Well, for the demo, it is pretty simple. We know we need to use bcrypt encoder in order to encode a value. So you can go to the main class actually, and in the main method, okay, you can get the same password encoder bean like this. So for example, you can get any custom UUID. random UUID dot to string. Then you can actually do something like this. You can use the bcrypt password encoder and you can call its encode method and pass it a key. That's it. And if I run this code, it will simply give me the encoded key for this raw key in the logs, and I can simply reuse this. Okay, so that's how you can create a dummy key for the demo. So that's all on the API key authentication, and in the next video we will cover JWT. Thanks for watching.